Hi, I'm Liam, aka Grey Rose, and welcome back to part 3 of the Road to the Hall of Fame, where we're trying to get to the Hall of Fame on XSSy.uk. We've already solved 10 labs, so we've got a lovely 10 points here, and now we're going to just keep going. Probably the next 5, so probably understanding the DOM is where we'll finish this one. But without further ado, we're going to go and capture some cookies. So this is a bit of a different one. Once you've crafted a working payload, you can submit it here, but you submit a URL pointing to the lab, and then you use that payload to capture the cookie. And once you capture that cookie, you then submit it below. So this is a little bit more realistic, as in how you might write a proper cross-site scripting payload. So instead of just having to, well, I guess better than that is instead of just having to alert it, you actually want to steal it, because if you were going to steal someone's cookies, then because you want to steal someone's cookies, right? You don't just want to alert them onto the page and show you them. You want to nick them so you can impersonate their accounts. So it's a little bit more of a kind of realistic attack against that. And then you get the little thing there. Back in episode 1, I think I mentioned the access log and I kind of showed how it worked. So we're going to do a similar thing here. If we do image, we need an image tag here. On error equals 1. This will probably execute. It does. Lovely. Let's go back here, and let's instead use script tags for this, because it's just going to be a little bit easier, and it means we don't have to mess around with single and double quotes as much. You'll understand what I mean in a second. So instead of doing this, what we can do is we're going to fetch our payload hosting lab like this. So as you can see, the website is not connected. Let's try this. So this is the access log is now live. We're just going to copy this, copy link address. We're going to do fetch like that. We're going to then end it with that. We're going to go, and then we're going to go plus document.copy. So I will show all of this properly, and then just after that, we're going to have to do mode no cause. Cause is cross-origin resource sharing, and the cause dictates how web pages are allowed to interact with one another. So what it stops it doing is a web page is not allowed to request another web page and then access the response unless the targeted web page sets a set of headers. There's actually there's a great video by an ex-colleague of mine called Corey Turner, who currently works for KPMG. He is I think it's Corey Turner of course, how to do cross-origin resource sharing improperly is by B-Sides Belfast. So I would very much recommend going and watching that if you want to understand cross-origin resource sharing a little bit better and the rules behind it. But anyway, we're not doing that now. The WebSocket is just disconnected there, so we're just going to refresh that quickly, and we're going to say fetch and then mode no cause there, and then we're just going to kill our script tag there. So if we then submit this, this should then is this going to work? Yeah, you can see that the flag is there. So we've successfully submitted this. What that looks like in here, just so you can all see the whole payload, is script fetch this and add document.cookie, which kind of appends it to the end. So it's just given us a URL parameter. And then mode no cause means that this can't access the response to it, but it means it also won't fail because this doesn't correctly set the right headers. We could force, and I think in some of the later labs, you occasionally have to set a custom header here, which does allow access control allow origin all, or does set the access control allow origin header properly. In this instance, though, we don't really care, so we're just going to grab that instead. Let's just reload this page quickly. Let's go and grab this. Let's send this to our victim. I'll stop spinning in a second. Payload's been submitted. We should then have flag equals that on there. And then if we go back here, we can then submit that. Successfully solved. Great success. So that is, again, a little bit more of a realistic exploitation of cross-site scripting. So what while we use alerts, and we alert in this set of labs, we use alert document.cookie. In pen testing, you use alert 1. In bug bounty, most people use alert 1. Most bug bounty hunters should not be using alert 1, but that's a kind of topic for a different time. We instead actually exploit this. So what we'd have actually done there is we'd go here and then we'd replace our, we go to here, where is it? Application, then cookies. So we'd go in here, and you can see we've got a flag cookie there. We'd actually just replace that with that. And what that means is that we'd now reload the site and would be logged in as that user, which is pretty cool. So cookies are for closers. Let's try open this, and I think this is the first one that is not written by Padge. So this is created by Mechatech, who's currently joined first alongside myself on the platform. And so let's have a look at what Mechatech's cooked up. The names get a little bit funkier from now on. So up to this point, you can normally guess what the lab's going to be about based on the name of it. Now they get a little bit funnier. I think I named some of my labs something that was trying to be funny. At least that's something I found funny. So let's do test here, and then we see we're reflecting that inside a text area. Yeah. So I'll show you what happens here if we just try and inject our payload. Get rid of that. So let's do a script tag, alert 1 script. You can see because it's reflected inside a text area, everything inside a text area tag is treated as text. So if we just do that, you can see that it's not doing any, well, it's actually Burp thinks that's a valid script, but when the browser interprets it, it doesn't. So all we have to do there is very cheekily just kill the script, kill the text area first, and then inject our script tags. But when that's now processed, you can see we get a lovely alert 1 there. And when we go here, you can see text area is then closed out of, we have a script, alert 1, and our script. Nice and simple. So all we do here, switch that out for document.cookie, make sure that that's still executing. It is, beautiful. We'll then grab this and we'll go and solve this lab. Drum roll, please. Woohoo! Nice. Right. Next one. We've got beating encode URI, file upload XSS, and then understanding the DOM. So let's do beating encode URI. I think this is a lab I wrote. It is. There you go. So beating encode URI. Let's kill that. What are we going to be doing here? Now, word of warning, I really like a language called JavaScript. That we've been using, and I really like it because it's quite strange and there's some very kind of weird behavior it exhibits. For that reason, I really enjoy a version of cross-site scripting called DOM-based cross-site scripting, a version that I've spoken at length about, which I won't bore you about here, but it is quite interesting. So what we're going to do here is if I just put test in there, you can see there's nothing on the page. I think I was a bit lazy, right? When I did this, but you can see that we're going to function tracking search, eval, new URL parameters, new URL search parameters. So what we're doing here is we're grabbing the search parameters. Actually, let's send this to repeater. It's going to make a little bit more sense. You can see that our search term is not actually reflected here, and you'll see why. The URL search parameters is a new URL search parameters of window location or search. The search term is encode URI. URL parameters get name, and then we're going to run tracking on the search term. Now, you may think we can break out of the, and then that is then evaluated. This string is then evaluated. So document.getElement by ID tracker in a HTML equals image source plus search term and there. So if we actually inspect here, so this is the DOM. You see image source equals test there. So what we normally try and do is we try and do this 1%20, then on and then on error equals what, right? And now this hasn't worked. Now you can see that we've actually got quite a lot of encoding going on there. That's because of the encode URI call. So encode URI is going to take a load of parameters and it's actually going to encode them. Interestingly enough for us though, there is a character it doesn't encode, and that is a single quote. So instead of trying to malform our image tag, what we're actually going to do is we're going to attack our eval statement. So we're going to add a single quote, which was then going to close this off here. We're going to add a semicolon. We're then going to do alert1, right? And then we're going to do 2 forward slashes. When we load that, that now fires because you're attacking the eval statement, not the image tag, right? So here is where our execution happens. Now you also note that this never actually hits the page. So this is where you've got to do your DOM-based cross-site scripting testing in a browser where it's actually rendered and you can see things. So this is going to be our thing. This is going to be our payload. We're going to use document.cookie there. We're going to get another set of execution there. So it is executing, and then we can now nicely grab that. Oh, see. Let's see if this is going to work for us. I've successfully solved. Next is file upload XSS. Now, I actually don't remember how we solved this one, so let's go and figure it out together. Okay, so we're going to choose a file. We're going to submit something. Let me grab a text file. Test.txt. I'm just going to save it. Test.txt. Do this over here. Documents. To frame. Save. Cool. So let's choose a file. It's going to pop up like that. Ooh. Let's go. Open it. So test.txt.txt. Then we submit that. It's going to be file uploaded there, and we can actually see that there. So let's do this instead. Now, there's probably a few ways we can do this. If we post there, we can see that it's uploaded and uploads. There's 2 ways I think from memory we can solve this. Oh, let's not do that. Let's go to repeater. There's 2 ways from memory I think we can solve this. I'm going to do it this way. Like so. I'm sort of going to upload a kind of an HTML kind of bit of content. Then you can see that it's test.html now. If we were to go to, and it's slash upload test.html, we now get an alert on the flag. So we can then submit this to our thing there. There are other ways you need to test these. Specifically, you need to test the name as well. I think that's actually a later lab. But yeah, file name XSS. So I've kind of given the game away there of what that's or how we're going to solve that one. But that's the standard way. So if something allows you to upload HTML to a site, then you can inject your script tags into that. You can execute it, and actually executes within the context of the site, unless they've. So you can normally access cookies on the site. So if something's authenticated, you could do this cookie stealing. You could do whatever you want. There's more advanced XSS attacks as well, but this site focuses on finding the XSS. There are other areas where we can, well, the other teaching material that I can share that it focuses on actually exploiting it properly. So last but not least of this one, we're going to do understanding the DOM, which is another one I wrote, and I definitely don't remember how I solved it. So let's go test here, and you search for test. Let's just go quickly. Peter, send this quickly. So this works a bit like the other one. function tracking search, document get element by ID tracker, inner HTML equals search, and then URL params, get the URL params, and then just run tracking on the search term. So this is probably even slightly easier than the last one because it doesn't involve an inner call. And we actually did this. This is very similar to the basic DOM-based cross-site scripting that we saw, but it instead grabs it from the get parameter from the URL bar as opposed to from the URL search parameters as opposed to being reflected within an input. No, so it's a variation on a theme. However, nice and simple, same as with the last one, because it's a in a HTML call. We're just going to use r on error equals alert. There. Boom, and that's going to trigger it. We'll go back for a sec. We'll just swap that out for document.cookie. The rest of it there. That'll then call alert document.cookie, and we very easily have just solved that one. Advantage of this version of DOM-based cross-site scripting, as opposed to ones where it's kind of reflected and then read out and then reflect and then hit again, is you can actually just do almost a code review to track it down. So you know your sources. Your source here is going to be your URL params because it's grabbing it from window.location.search, and then your sync is going to be when it's reflected back into the DOM. DOM XSS is the hardest form of XSS, I think. Script context XSS might be more challenging. I think it's probably a toss up between the two, or JavaScript injection. But that is, and the reason why is because script tags don't fire. But anyway, thank you very much for tuning in for part 3. I hope you enjoyed yourselves, and we'll catch you next time. Cheers.